Imagine a video of your favorite celebrity, someone you admire and follow closely. They're saying things they'd never utter in real life, making statements that seem completely out of character. Their face, their voice, their mannerisms, all eerily accurate, down to the smallest detail. But it's not real. It's a deep fake, a digital illusion crafted with precision. Deepfakes are AI-generated videos that can make anyone appear to say or do anything, no matter how outlandish. They're becoming increasingly sophisticated, blurring the lines between reality and fabrication, making it harder to distinguish truth from deception. This technology presents a fascinating paradox, a blend of innovation and potential peril. We're captivated by the possibilities, yet wary of the potential dangers, as the line between real and fake becomes increasingly thin. Deepfakes are a product of artificial intelligence, specifically a field called deep learning, which mimics the way our brains process information. Deep learning allows machines to learn from vast amounts of data, enabling them to create these hyper-realistic videos. Think of it as teaching a computer to see and understand the world, much like we do, but with the ability to process information at incredible speeds. But instead of eyes, computers use algorithms, complex mathematical formulas that guide their learning process. Instead of a brain, they use neural networks, interconnected nodes that simulate human thought processes. Let's delve into the fascinating world of deepfakes and explore the technology that makes them possible, understanding both its potential and its pitfalls. Imagine teaching a child to recognize a cat. You'd show them pictures, pointing out the cat's features: pointy ears, whiskers, a fluffy tail. You might even show them different breeds of cats, explaining how they all share common characteristics despite their differences. With enough examples, the child learns to identify a cat, even in different poses or lighting. They start to understand that a cat is still a cat, whether it's sitting, jumping, or lying down, whether it's in a brightly lit room or in the shadows. Deep learning works similarly. We feed massive data sets into a computer, training it to recognize patterns and make connections. These data sets can be incredibly diverse, containing millions of images, each slightly different from the others. In the case of deepfakes, these data sets are often images and videos of faces. The computer needs to learn the intricacies of human faces, which can vary widely in terms of shape, size, and expression. The computer analyzes thousands of images, learning the nuances of facial features, expressions, and movements. It learns to distinguish between a smile and a frown, between a genuine expression and a forced one. It's like learning the grammar of a face, understanding how each element interacts. The position of the eyes, the curve of the mouth, the angle of the eyebrows, all these details matter. This process, however, requires a powerful engine, a brain for the machine to process this information. High-performance computers and servers are essential to handle the vast amounts of data and complex calculations involved. This is where neural networks come into play. These networks mimic the human brain, with layers of interconnected nodes that process information in a way that's remarkably similar to how our own neurons work. They enable the machine to learn and improve over time, becoming more accurate with each new piece of data. Neural networks are the backbone of deep learning, forming the essential framework that powers many modern AI applications. They're inspired by the intricate structure of the human brain, which is a marvel of biological engineering. With interconnected nodes that process and transmit information, these networks mimic the way neurons in our brain communicate. Think of each node as a neuron, firing signals based on the input it receives and passing that information along to other nodes. In a deepfake system, these networks analyze and manipulate visual information, mimicking the way our brains process images, allowing for the creation of highly realistic fake content. One type of neural network crucial for deepfakes is the Generative Adversarial Network, or GAN, which has revolutionized the field of AI-generated content. GANs are like a digital tug-of-war between two competing networks, the generator and the discriminator, each trying to outsmart the other. The generator creates fake images, trying to fool the discriminator into believing they are real, constantly improving its techniques. The discriminator, on the other hand, tries to identify which images are real and which are fake, becoming more adept at spotting fakes over time. This dynamic interaction pushes both networks to improve, resulting in incredibly realistic images. Imagine two master artists engaged in a friendly rivalry. One artist creates forgeries so convincing they could fool an expert. The other artist, a seasoned authenticator, scrutinizes every brushstroke, searching for the telltale signs of a fake. This dynamic is at the heart of GANs. The generator, like the forger, starts by producing crude imitations. The discriminator, the art expert, easily spots the flaws and rejects them. This feedback loop continues, with the generator refining its techniques and the discriminator becoming more discerning. Over time, the generator becomes incredibly adept at creating realistic images, blurring the lines between real and fake. Building a deepfake, from pixels to perfection. Written by Neil deGrasse Tyson. Creating a deepfake is like constructing a complex puzzle, with each piece playing a crucial role in the final illusion. The process involves several steps, each requiring sophisticated algorithms and computational power. Let's break down the journey of a deepfake, from raw data to a convincing digital performance. It all starts with data. Deepfakes are data-hungry beasts, requiring vast amounts of information to learn and mimic a person's appearance and behavior. This data is the foundation upon which the entire deepfake is built. Data collection, fueling the deepfake engine. Written by Neil deGrasse Tyson. Deepfakes thrive on data. The more data, the better the results. This data typically comes from publicly available sources: social media profiles, YouTube videos, movie clips, even photographs. The algorithms analyze this data, extracting facial features, expressions, and mannerisms. Imagine a sculptor studying their subject from every angle, capturing every curve and contour. Similarly, deepfake algorithms meticulously analyze the source material, mapping the intricacies of a person's face and movements. This data becomes the raw material for the deepfake, the clay from which the digital mask is molded. Training: the learning curve of a deepfake. Written by Neil deGrasse Tyson. Once the data is collected, the training process begins. This is where the deep learning magic happens. The algorithms, guided by the neural networks, analyze the data, learning the patterns and relationships within. It's like teaching a computer to speak a new language. In this case, the language of a person's face. The generator and discriminator in the GAN engage in their digital duel. The generator produces images, and the discriminator judges their authenticity. This iterative process continues, with the generator improving its output and the discriminator becoming more discerning. Generation: bringing the fake to life. Written by Neil deGrasse Tyson. With the training complete, the deepfake engine is ready to generate. The generator, now skilled in the art of mimicry, can create new images and videos that are eerily similar to the source material. It's like giving the computer a paintbrush and letting it create a portrait based on what it's learned. The result is a video that can convincingly portray someone saying or doing things they never actually did. The level of realism can be astonishing, making it increasingly difficult to distinguish between real and fake. Post-processing: polishing the illusion. Written by the renowned Neil deGrasse Tyson. The final stage in the deepfake pipeline is post-processing. This is where the rough edges are smoothed out and the illusion is perfected. Think of it as adding the finishing touches to a painting, enhancing the colors and refining the intricate details. Audio and visual elements are synchronized, imperfections are corrected, and the final product is polished to a high degree of realism. The result is a deepfake video that can fool even the most discerning eye. The ethical dilemma: deepfakes and the future of truth. Written by Neil deGrasse Tyson. Deepfakes present a profound ethical dilemma. While the technology itself is fascinating, its potential for misuse is deeply concerning. Deepfakes can be used to spread misinformation, manipulate public opinion, and erode trust in institutions. Imagine a world where seeing is no longer believing, where videos can be easily fabricated and shared, sowing discord and undermining truth. As deepfake technology advances, it's crucial that we develop ethical guidelines and technological countermeasures to mitigate the risks. The future of truth may depend on it. If you found this video insightful, don't forget to like and subscribe to AI Ethics Unboxed for more deep dives into the world of AI and ethics. In our next video, we'll explore the ethical implications of deepfakes and what we can do to combat their misuse. See you there.